To write the Lewis structure for AlI3, this is aluminum iodide, the first thing we need to do, count the valence electrons up. Aluminum on the periodic table is in group 13, sometimes called 3A, so it'll have 3 valence electrons. And then iodine, that's in group 17, sometimes called 7A. It has 7 valence electrons, but we have 3 iodine atoms. So we have 3 plus 21, 24 total valence electrons for the AlI3 Lewis structure. Aluminum is the least electronegative. We'll put aluminum in the center, and then we'll put iodine atoms around that. So we have 24 total valence electrons. We'll put a pair of electrons between each iodine and aluminum atom. That's going to form our chemical bond. Then we'll complete the octets on these iodine atoms. So at this point, we've used all 24 valence electrons. Each iodine atom, that has an octet, so those are all good. But this aluminum in the center, it only has 6 valence electrons. Aluminum is an exception to the octet rule. It can have only 6 electrons and be okay with that. Boron's another exception that only needs 6 valence electrons. So this is the Lewis structure for AlI3. If we wanted to look at the molecular geometry here, we could see there are 3 things attached to this central aluminum. We have 1, 2, 3 iodine atoms, and there's no lone pairs on the aluminum. So if we look at our chart here, we can see our steric number is 3. That's the 3 iodine atoms. And we have no lone pairs. So we're going to end up with this trigonal planar molecular geometry. If you use the AXE notation, you'd have A, that's the aluminum, the central atom. The iodine, that's the X, 3 iodines. And then the E, the lone pairs, there aren't any. So you really just have AX3. If you look that up, you'll see that that's trigonal planar. This is Dr. B with the Lewis structure and molecular geometry for AlI3, aluminum iodide. Thanks for watching.